guys, now we will solve structure bar problem. So this is the problem. So we need to determine the displacements as well as the reactions of this bar. Okay. Now let's see. So we have already solved by using theoretical one. Then same thing we are solving by using analysis, that is Unpress method. So right now we start with analysis multiphysics. We go to the file, change job name as experimental node, say okay. Go to the file once again, change directory, change title. So right now we are solving step bar problem. Write as step bar. So go to the preference, click on the structure, okay. Then go to the preprocessor, go to the element type, add edit, add, and click on the link, select both. Then go to the material models. So here in this problem we have three different materials and three different cross sections. So that means we have created three elements with three different materials as well as three different cross sections with the different lengths. Okay. So here go to the material models and create the material. So right now this is my first bar, this is my second bar, and this is my third bar. Okay. So for first bar, so right now I'm creating the material. So go to structure, click on the linear, inelastic, isotropic. So you check what is the instance for the first bar. It's a 70 gigapascal. So you have to convert it to Newton per mm square. That means 70 e to the power of 3. And Poisson's ratio is 0.6. Now create another model, sorry, another material model. So for that, you just click on the material, click on the new model. So to create material ID as second, that means the different second material. You say okay, then once again click on the isotropic and look for the Young's models for the second one, that is 105 gigahertz. So once again, it's a 105 e to power 3.3. Say okay. Then once again we have another material with the third one. So that is once again go to the material, new model, click OK. So then click on the isotropic. So what's the Young's models for this third one? Is 200 gigahertz. So convert it to Newton per mm square. So 200 e to power 3 Newton per mm square. 0.3. Say OK. So now we have created the material property. So just close it. Now go to the section. Now we need to create our area. So that means we have to define the area of one different bar. So link with the add, right, as one because we have three bars. So first ID is one. We just check for the area for first bar is 900 mm square. So write as 900 here. Say once I click on the add, now change the ID to second. Say OK. Check for the area for second bar is 400. Write as 400. So once I go to the add, now change the ID to 3. Say OK. And area for the third bar is 200 mm square. So write as 2. Now we have created, so we have defined the type of element, assigned the material property as well as the area for the particular bar. Now go to the modeling. We need to create our geometry. So now I'm once again using the measured element. So for that we create the nodes, click on length, and click on it. So right now here we need to create the 4 nodes. So here one, this is second, this is third, and this is fourth. Okay. So just write as 1, x equal to 0, y equal to 0, z equal to 0, 0. Then go to the unit coordinate system. Then write as second node. So what's the second node? What's the length of the first bar is 8 meters. So write as 80 here, that is x equal to 80, say apply. So it will create your second. Then write as third node. So what's the distance of the second part from this first node? That's 80 plus 90. So just add plus 90. Say apply. Then create a fourth node. Check the length of the third part from this first node. That is 80 plus 90 plus 70. Just write plus 70. That's it. So here you can see we have created a 4 nodes. Now we need to create the elements by using all these nodes. So for that, let's go to the elements, go to through nodes, just click first and second node, so it create our first element. To create the second element, again we need to change our material as well as the area. So for this, we just go to the element attribute, change this material number to second as well as section number to second. So generally in previous year ANSYS software, here you can change your cross section, that is real constant. Okay, so now it has changed to the section number. So now we have defined the second element. Then once again go to the through nodes, just click on the second and third node, it will create our second element. So similarly, third node, if you want to create the third element, once again the area as well as the material is different. So once again we change the element attribute to third. That is, go to the material model, click on the third, as well as go to the section model, click on the third. So it will change to your material models as well as the section number to third part. So go to once again through nodes, click on the node 3, click on the node 4 and create the element third. So this is nothing but discretization. So what we have done here, we have discretized the geometry into our FA model. Okay. So now how to view this similar kind of problem. So for that, go to the plot control, go to the style, click on the side and shape, and just check this display of element to on and see. So for that, go to the plot and click on element. So this is a step by plot. Okay. Now till now what we have defined, we have defined the element type, that is then section, modeling, then material property. So left with your load condition, that is boundary conditions. So just go to your solution, go to your define rules, apply, click on the structural, go to the displacement and click on the nodes. So right now we have the nodes and element, just click on the nodes. So we are seeing problem where it is fixed. It's fixed at node 1 as well as node 4. Okay, so just click on node 1 and node 4. Say OK and consider all negatives and say OK. So once we constrain this both the ends, now we need to apply the forces. So where we have the forces at node 2 and node 3. At node 2 we have 20 kilonewton in tension, that is in positive direction. So that is for to apply the force, just click on the force and moment, click on the nodes, click on the second node, OK. What's the value you can see here? 20 kilonewton. So just write 20 e to power of 3 and say OK. Now to create one more force at node 3, once again we have to go to the force moment, then click on the nodes, just click on at node 3. So and click say OK. So what's the value of this force at node 3? We have this 10 kilonewton. That is 10 kilonewton. Okay. So write as 10 e to power of 3 and say OK. Now we have created our geometry. So once it's done, then just go to analysis type, new analysis, look for this is static or not. If it's static, then say OK. Then go to your solution and solve the problem. Once it says solution is done, then problem is solved. Okay. Then to view our result, go to general post processor, then go to your general post processor list results. In list results, we can view our results. That is nodal solution in that degree from that is nodal solution in that displacement vector sum. Just click OK, you will get the deformation at each node. Okay, so here you can see 0.2345, that is 0.0235 at node 2 and 0.02017 at node 3. It's in MN. Okay, now to know the stresses value, just click on the element solution, click on this known the stresses and save. So at element 1 we have 20.523 Newton per mm square. Element 2 we have minus 38.84 Newton per mm square, and element 3, as you can see here, element 3 we have the value of minus 57.6 Newton per mm square. So these are the thermal stresses in each element. Now next we need to calculate our reaction forces. For that, go to the reaction solution, click on all item and shift OK. So it will give you the reaction forces at node 1 as well as node 2. So in node 1 we have minus 18,417 Newton, and node 4 we have minus 11,530 Newton. So now how to verify this also without just cross checking also. So here you can go to the here you can see, yeah. So here you can cross verify your answer. So once again I will open my solution. So at node 2 we got 0.02345 and at node 3 we got 0.0201. So here you can see. So at node 2 we got 0.02345 mm and at node 3 we got 0.0201. So that means our solution is correct. Okay. Now stresses in each other. So let's go to once again our element solution. What is the stresses? So we got this 20.523 Newton per mm square per megapascal. Here it is 20.517. It's megapascal in Newton per mm. This is stress in first element. If you want to calculate stress in second element, then you can get this value as minus 3.82 Newton per mm square. And element 3 is 57.62 Newton per mm square. Now to view the reaction process, here you can see that the reaction process. So how much we got? Minus 18.47 into 10 power of 3 Newton at node 1, and reaction force at node 4 is minus 11.525 into 10 power of 3. So if you see your answer's value, so you will get here go to the reaction solution, click OK. So you will get same value. That is at node 1 we got minus 11,470 Newton, whereas at node 4 we got minus 11.50 Newton. Okay. So to view the same results on this drop bar, and for that what we have to define the table. Go to the define table and then write as first force, there is a reaction force. So you look click on the force number and here SMS1. Write as SMIC. So what it says SMIC, just to know about all this abbreviation, just click on the element component. Okay. Now see, then go to the add, write as stress by sequence on LS, click 1, go to the add, once again write as string, that is nothing but your deformation by sequence number, click on this NEEL as 1, save and close. Now, so here you can go to your plot result in that contour plot and in that element table. So now we are calculating the forces. So right, just click. So how to view this? You just go to the plot contour, click on the numbering, and here number contour value. Just click on and see. So you can see. To remove this maximum minimum, just go to the plot control, go to the window control option, and you remove this minimum maximum symbol. and you can see the value of your reaction forces at each node. Okay. Now, to know the stresses in each element, just go to your once again dot plot in that element table and change to stress and like okay, so you get the stresses in each element. Then to get the strain, that is deformation in each node. So just like on strain, it's equal, so you'll get the deformation at each node. Okay. Now, how to move this 1D element into 3D view? Just change it into isometric, then go to the plot control, style, then size and shape. Click on the display of element and say so plot control, animation, deform shape, deform, undeform, zip. Yeah. So this is the name what you call deformation. So here you can see deforming at node 2 as well as at node 3 and it's fixed.